In this lesson, we'll be talking about solving 3 by 3 systems of equations. Okay, so this is what it looks like. In section 3.1, we've talked about how to solve systems that were 2 by 2. So there were two equations with two unknowns. And so we know how to do that. We talked about substitution, we talked about addition method or elimination method, and we talked about graphing, right? So we talked about what happens if you have infinitely many solutions, how you can tell. We talked about if you have no solutions, and we talked about how to confirm something if it was a solution. So all those things we understand with 2 by 2. Now the question is going to be, how can we do a 3 by 3? Okay, well, so for a 3 by 3, what the goal is going to be is to turn it into a 2 by 2. Because if we turn this into a 2 by 2, then you know how to do that. So kind of the way in which we'll do that, if this is our equation 1, if this is our equation 2, and if this is our equation 3, will be to take, you have to just pick two equations. So you have your choice. I mean, you can pick any two. So let's say we pick equation 2 and 3. And now you want to pick a variable to eliminate. So let's say we want to eliminate variable z. So that's fine. We've made that decision. Now we need to stick with our read. Okay, we have to stick with our decision. So we have to make sure that we eliminate z, and we're going to have to eliminate z again in a moment. So what we're going to do is, let's take equation 2, equation 3, and so equation 2 and equation 3, and let's add those together. Okay, so let's just take equation 2 and 3 and add them together, and then that will eliminate z for us. So I don't have to multiply them by anything. I can just leave them as is. And okay, so if I add these two equations, I'm going to get 3x plus 2y. Z's are gone, and that's going to equal 4. Now, that I'm going to call equation 4. Okay, now let's go off to the side, and we'll leave that there for a moment. Okay, now I need to pick a different two equations, like a different set of equations. Remember, this was equation 2 that I had selected, and equation 3, and I picked those two and I eliminated z. So now I have to pick a different two equations. I've already picked 2 and 3. So of course I can use 2 or 3 again. I mean, in fact, I would have to, but I can't use those same two equations. So I'm going to have to pick 1 and 3 or 1 and 2. So once I pick those, then I have to eliminate z again. I have to eliminate z again. The same thing that I eliminated, I have to eliminate again. If I had chosen to eliminate y, that would have been fine, but now I would have to eliminate y again. Okay, so you have to stick with it. So let's choose equation 1 and equation 3. Okay, now notice I'm going to have to multiply equation 3 by something. Or I'll tell it. Let's choose equation 2. Okay, let's choose equation 2. And equation 2, I'm going to have to multiply by something to get this 6 to cancel. So how about I multiply equation 2 by 6? So let's multiply that by 6. Okay, so when I'm writing this means I'm going to take equation 1, I'm going to add that to equation 2 once I've multiplied equation 2 by 6. So first I'm going to have to take 6, multiply by equation 2, then I'm going to add that to equation 1. Okay, and so let's put those steps here. So first let's do this part. Okay, so let's do 6 times equation 2. So 6 times equation 2. Hold on, I don't want to put more parentheses there. I want to put more parentheses there because I want to multiply everything by 6. So that's going to become 12x plus 6y minus 6z is equal to 12. Okay, so that's my new equation 3. Okay, I don't really want to call this equation 5 yet because I'm going to kind of have a special thing for equation 5. But this is my new equation 2. Okay, and so now I'm going to have to take that, I'm going to add that to equation 3. So remember, what was equation 3? Equation 1. I'm adding it to equation 1. So equation 1, remember, was 3x plus 9y plus 6z is equal to 3. Okay, and so remember, this is 6 times equation 1, and this is our equation 2, and now I'm going to add them together. I'm sorry, this was 6 times equation 2, and this was our equation 1. Anyway, when I add them together, I'm going to get 15x. This is going to be 15y, and then my z's are gone, and I get 15. Now, since they all have a 15 in common, in fact, you could factor out a 15 on this side, and then you can cancel those sides. So really, this is the same thing as saying x plus y is 1. Now that you don't always have to reduce there. If you didn't notice that, it's fine. You can just leave it. But we'll call out our equation 5. And again, if you hadn't reduced, you can call this your equation 5. It would be fine. This one up here, it would still work out fine. So now equation 4 and 5. Look, equation 4 and 5. If I write them here, then that is going to make it's 3x plus 2y is 4, and x plus y is 1, and that makes a 2 by 2 system. So see, this is a 2 by 2 system. So now I have a 2 by 2, and we know how to solve those, right? That's our usual thing that we've been dealing with. So all you have to do is solve this 2 by 2 system, and then you'll know what x and y are. And once you know what x and y are, you pick that x and that y, and you pick any one of these original equations or any of the equations that you've gotten along the way, and you plug them in, and you'll get z. Okay? So let's take equation 5, and let's multiply that by, say, negative 2. So let's take equation 4. I'm running out of space, so I'm kind of shortcut this. So I need to take this equation and multiply it by negative 2 because I want to eliminate my y's. So this becomes negative 2x minus 2y is negative 2. And if I add these, then I'm going to get x, the y is gone, and I'm going to get 2. So I'm going to get, that means now I know that x is equal to 2. So since I know that x is equal to 2, I now just plug this into our second equation here, like this is our equation 5. If I plug that into 5, then I know that 2 plus y is 1. So if I move that to the other side, then that means that y is going to have to be negative 1. Okay, so now I've got my x, I've got my y, and so now I just pick any equation at all, and I can find z. So by plugging these in. So let's pick our equation 3, our original equation 3, because those those coefficients are low. So remember, x was 2. So if I plug this in, I'm going to get 2 for x plus negative 1 for y plus z, which I don't know, is equal to 2. When I add these, I'm going to get 1 plus z is equal to 2. Then that must mean that z is 1. So that means that my solution set, it's not an ordered pair now, it's actually what we call an ordered triple. So you're just going to put them in order. X was 2, y was negative 1, and z was 1. And that would be our solution. Okay, and so that's the solution to our 3 by 3 system. So essentially the problem is take any two equations and eliminate one of the variables. And then you pick any other two equations and you have to eliminate that same variable. Then you have to a 2 by 2 system, and then you solve that like usual. And then you go from there. And so again, our steps to solve are: number 1, we're going to pick a pair of equations and we're going to use the addition method to eliminate a variable. Okay, so we're going to pick a pair. So we're going to pick a pair of equations and we're going to use the addition method, or it's the elimination method, either one. And we're going to eliminate a variable. So that's what we want to do. We want to eliminate a variable. So like in that last example, if we look back to show that I did that. Okay, if I look back, I first picked equation 2 and equation 3. Okay, and I wanted to eliminate z. So that means all I had to do was add them, and then those were able to eliminate. And so I got a new equation. Okay, and then proceeding forwards, okay, what we had to do is we had to pick a different pair of equations and then use the addition method to eliminate the same variable. Okay, so that same thing. So now I'm locked into x. I have to, or I'm sorry, z. I had to eliminate z again, so I picked a different set of equations. Okay, I picked 1 and 2, and so I have to eliminate z again. So remember, to eliminate z, that means this is going to have be a 6, so I'm going to have to multiply this whole thing by 6, and that's why I took equation 2 and multiplied it by 6, added it to equation 1, and then when I got that, I got this equation. Okay, and so now I use the resulting equation from steps 1 and 2 to form a system of two equations with two variables, and then I solve that system within any method I liked. And I mean, I just chose addition because that's what I was used to. And then the last part is you take those two values that we found in step 4 and you plug them into one of the originals and you solve for the third one. That's exactly what we did. Remember, we took the equation 4, equation 5, and we put them here as one system. We then solved this system by finding x and y. So how we did that is we eliminated y here, and we got x was 2. We took that and we plugged that value into this bottom equation to get what y was, and once we got y was -1. And then once we knew those two values, then we took those and we plugged those into our third equation, equation 3, and we got z was 1. And so that was our solution. And so that was the steps. Okay? And so that's how essentially you solve one of these 3x3 systems.